you today. What form is this first one given in? Go ahead and just say it. That's standard form. Okay, so you need, like for this quiz, you need to put standard form information on your card unless you have it memorized, which is what I would like you to do. So in standard form, what do we know right away? Just say y-intercept. Y-intercept is what? Yep, y-intercept. We can see that right away. Okay, in terms of the vertex in standard form, remember it's at negative b over 2a, and then f of negative b over 2a. And that looks a little bit messy and complicated, but remember it's really not, because f of just means plug whatever you got for the x coordinate in. Okay, so we'll do that. The x coordinate is negative, what is b? 5 over 2, what is a? 2. So this is negative 5/4. Okay, and then the y coordinate. Or what else could we label these? Actually, let me do that in a second. So again, it's just f of. It just means plug in the negative 5/4 to the function, which admittedly is a little bit ugly on this one. But you'll be able to use a calculator. Negative 5/4 squared is positive 25/16. So that becomes 25/8 when I multiply by 2. And then let's just do minus 25/4 minus 3. Okay, and I'm just trying to avoid punching all this into a calculator. So let's just make everything eighths. So this is 25/8 minus 50/8. That doesn't look like an 8. Minus 24/8. So what do we get? Negative 25, negative 49/8. Okay, there's our y coordinate. What is that roughly? Like when I go plot that on the graph, it's not like I'm going to get it down to the eighths. So what is it roughly? Huh? Yeah, it's roughly negative 6. Awesome. And negative 5/4 is just a little bit over negative 1. So we're like somewhere in here. And here's what I mean. By the time you fill in a dot, you're covering kind of a lot of ground. So it's not like it has to be perfectly on the eighths. Okay. So our vertex was at negative 5/4, negative 49/8. Okay. Is this opening up or down? It's opening up. A is positive. So positive. And so what does the 2 do? Stretch by 2. By a factor of 2. Let me actually write by a factor. By a factor of 2. Okay, so I'm just going to ballpark this. Like if this is the original, which it's not, that was ugly. If that's the original, then this is going to look what? Narrower or wider? Narrower. Okay. In terms of graphing, the normal pattern is over 1, up 1, over 2, up 4. Right? So 1 squared is 1, 2 squared is 4. But now we're doubling that. So it's over 1 and up 2. So somewhere like here. And then over 2, up 4, up 8, I mean. So somewhere like there. And then we can just reflect over the axis of symmetry. And I'm just, again, just kind of ballparking that. Something like that. If you make it a V, I will mark it wrong. Why? Like if you arrow point that like that. Joe.
Because that's a different function.
Exactly. That's not even this function, right? So make sure you do round it down there at the bottom. Okay. Always graph before you do key features. At least that's my advice. I think you can do better that way. So it says give the key features. I think we're ready to do that now. What's the domain? Infinite. That doesn't really change in a parabola. Unless we're in context, then it does. So be careful with that. Meaning if I'm shooting a ball, I can't have infinite in both directions. It doesn't even make sense, right? So we've got to do realistic. Can you not do that right now? Like, pay attention. Range. What's the range of this guy? It starts roughly at -6. It's technically -49/8 to infinity. Good? Okay, and then we can do intervals of increasing and decreasing. Let's do decreasing first. I think it makes more sense because we read graphs left to right. Just reminding you, I'm going through this kind of quick, but you'll need to be able to do this for this quiz, all of it. So graph, find the vertex, plug stuff in, find key features. Where is it decreasing? Downhill, left to right. Okay, I'm walking downhill all the way to that pink dot, right? So decreasing is downhill. So it goes from -infinity to our x coordinate of our vertex, which was -5/4. How about increasing? Yeah, now we're climbing uphill, going again left to right. So it starts at -5/4 and goes to infinity on the increasing. Okay, positive, negative. Let's review that real quick. Where is this positive? Remember, positive means y values above the x-axis. No. X values go in our interval. Okay, we're saying look where it's above the x-axis, but tell where that happens on the storyline, which is the x-axis. Right? We're like, this is like the timeline. If you think like a YouTube video, the x-axis is your timeline. Like, oh, I'm at 5 minutes. Oh, I'm at 9 minutes and 30 seconds. And then you're just watching the video of what's going on with your graph as you look. Yeah, we didn't find the x-intercepts yet, but roughly, I mean, based on the way I graphed it. So let's come back and fill that in, and then it's going to come from our other x-intercept and go to infinity. So we'll need to find those x-intercepts here in a second. Okay, and then negative, it's just whatever's in between those two. So that's just going to be in between our two x-intercepts. Does everybody see what I mean? Like wherever it crosses there and there, it's negative between them, positive on the other side. So let's do that part. We need to do this anyway because I told you to write it in both forms, both other forms. How do we find the x-intercepts? This was your homework, so let's see how that went. What? Yeah. First set equal to 0, so 2x squared plus 5x minus 3 equals 0. And then set up your star. Well, GCF, is there one here? No GCF. Okay, what is A times C? -6. B is 5. A is 2. This is the smallest star ever. Are there factors of -6 that add up to 5? What are they? 1 and -6. Okay, this side is good to go on the reducing. The other side, we can divide both by 2 and we'll get 1 over -3. So x minus 3. Okay, after, yeah.
How does 1 and -6?
Oh, I have it to the signs backwards. I was just checking. So let's fix that. Two x minus 1, x plus 3. That's better. Good job. Okay, can you look at those and tell me the zeros without solving them, like without writing it out? What's the 0 of the first factor? 1/2. So move the 1 over, divide by 2. What's the 0 of this next factor? -3. Okay, so now we have points there. Dude, check out my graph. It's pretty good, huh? All right, now we can go fill these in. So we are positive up to -3, and then positive again after 1/2. Now that we have those, plug that in there, and then here it's just those two. In between those two were negative. So you need x-intercepts for that part. Okay, last two things. We need to write this in the other form. So here's some advice. Do we know A? Yeah, we were given A. It's right there, right? That's A right there. So do we have to solve for A for vertex form? Do we have to solve for A for factored form? Okay. And I'm going to put these up here. So here's just something to keep in mind. We did a lot of work, and some problems don't ask you to do all that work, but in this case we did it all. So look down here. What is another letter for this right here? Sorry, I'm off the screen. What's another letter that we can call the -5/4? That's H, right? Didn't we find the vertex x coordinate? So that is H. What's another letter for this right here? That's K. Do you see how we can take that directly to vertex form? Which is what? Just what's the raw blank form of vertex form? Starts with A. A what? Okay. Now I just fill stuff in. I already know A is 2. So that's 2. X we leave. What's H? Negative. I don't need it twice. -5/4. What's K?
-49.
Okay, there's vertex form. So we didn't have to go do much converting. We already had all the pieces. We just plugged them in. Nice, right? If you're lost right now, you're in trouble. You need to come get help, okay? Everything we've done so far is review. So come ask for help today, please. Let's do standard form, or excuse me, factored form. What is raw factored form? So it's going to start with f of x, a, then what? I'm going to let him go. Go ahead. Thanks. X minus p times x minus q. So it's just factors. It's just the way, like we actually did that too, right down there, right there. That's factored form. Okay? Sorry. So we already did it. We don't even have to write it down. Or we don't have to really do anything. So this is 2x minus 1 and x minus 3. Is it plus 3? Plus 3. Thanks. X plus 3. Okay. Basically, that covers the entirety of what we've done in this unit so far. The only difference that you might get is instead of being given standard form, maybe I give you factored form and ask you to convert to the other types and graph and find your key features and all that. Okay? But it covers factoring, it covers solving, it covers key features, it covers what x-intercepts are and how we find them, at least in standard form and factored form. We didn't do it in vertex form, so that's something that's different. It covers finding the vertex in standard form. So that's most of it. I guess there's a couple things that we didn't do. Like vertex from factored form. Converting to standard form and solving in vertex form. Those are all, well, a couple of those things are in your notes. Do you want me to review those real quick, or do you want to just do some other problems? Yeah? Okay. I kind of thought you might, so that's good job for asking. Here's what I'm saying. Let's say I give you this. This is just an example. Maybe let's don't do a fraction for this one. Okay. So what form is that? That's factored form. So if I say, where's the vertex, how do we do that? Look at your notes. There is a pretty clear description of it in there. The both what? Okay. Average the x-intercepts for the x-coordinate of the vertex. So what are the x-intercepts? Yeah, remember we wrote in the notes, it's the opposite of what you see. So we have one at -3 and +4. So we just average those. It just means -3 plus 4 over 2, which is 1/2. So the x-coordinate of the vertex is 1/2. And what other letter is that? This is also H. Good job. Okay, how do we get the y-coordinate? Plug x in, yeah. So don't forget all the pieces that go around it, like that 3 out front. And again, just calculator says 1/2 plus 3, 1/2 minus 4 times -3, right? And I'm okay with that if you want to use it that way. So 1/2 minus 6/2 is -5/2. 1/2 minus 8/2 is -7/2. So what is that, 100? -105 over 4. That's kind of ugly, but that's okay. And what other letter is that? That's also K. So if I asked you to convert to vertex form, then you also have that now. Well, you have the vertex at least. All right. Actually, you have A as well. Look, it's right there. And without scrolling, it's -3. So you could write this in vertex form. Let's go ahead and do that. -3. What goes inside? Well, x and then minus 1/2 first, squared, and then plus or minus -105/4. Okay. All right, and then standard form. I would not use vertex form to do that. I would just go back to the original. And what were those? X plus 3, x minus 4.
Students and staff, pardon for the interruption. Students going on the construction field trip, can they please be released now and meet out in the front of the building? Students going on the construction field trip with Miss Giles, please meet out here in the front of the building now. Thank you.
Okay, here's my suggestion on this. And definitely follow it because students mess this up all the time. Do not deal with this -3 until you've dealt with multiplying the two parentheses out. In other words, I want you to add in brackets, do what's inside of those, and then multiply the 3 at the end. So I would do this as this kind of situation. Okay, inside we'll get x squared, and then we'll get -4x plus 3x. -4x on the outside, 3x on the inside, which becomes what? Yep, just minus x, and then minus 12 from the 3 times -4. And then distribute that -3. I promise this will go better if you do it this way. So that is how you go to standard form from factored form. Just redistribute is really all we're doing. Okay. Questions on that? Feel okay with that? There's one other thing that I want to review with you that you guys did bad on that little pre-quiz, and that is writing the equation for a function if you're given the vertex and a point. Vertex and a point. Or if you're given a point, the x-intercepts and some other point. So let's just remind you of that. It's in your notes. I feel like you just don't read them, though, sometimes. So that's why we're doing it again. So write the equation given the vertex and a point, and I'm just gonna have to make this up. Let's see, 5, 10. Let's say it goes over there. Something like that. What do we need to do on these? What do we need to do? Well, we're given the vertex. So what should we use? Yeah. And then, is that all you were going to say? Yeah, good. So plug in the vertex and point and solve for A. All right, this is the y coordinate, which is what? 10 goes there. We don't know A, it stays. And then we say, what's x? Five minus h, which was -3. And then plus k, which was 2. And now we just solve for A. Now we're just back to algebra 1. Okay? So 10, that looks like 19. 10 equals A times 8 squared. So that's 64A. Subtract 2. Again, this is just algebra 1. This is just solving a linear equation. Divide by 64. A is, do not say 8. It's 1/8. Are we done? Like, does that meet the demand of the problem? We have to plug in just A, H, and K. Remember, just those three things. So if you plug in X and Y also, you're going to actually just define a point. So plug in just A, H, and K. So we'll get f of x equals 1/8 x plus 3 squared plus 2. So that was just a reminder of how to do that kind. Now you can do the same process if I give you a point and the two x-intercepts. You would just plug it into factored form instead. Make sense? But you still solve for a. It's the same kind of idea. It's just that you're starting, this starting empty function would be factored form instead of vertex form. Give me some feedback. What are you feeling about this? Do you want to look at the review and then let me ask you? Okay, let's do that. Okay, if you ever work for Apple,